Geometry. So today's lesson was all about trapezoid properties. I know we were supposed to cover trapezoids and kites, but we didn't get to finish the lesson. So we're going to focus on trapezoids. You can use your study tool to help you. Alright, if you're not familiar with the vocabulary words I'll be talking about in this video, please use the study tool to help you. Alright, so here we go. One of the properties we talked about was something to do with the consecutive angles of a trapezoid. Alright, so the consecutive angles of a trapezoid are the angles that share the same leg. Alright, so what is the leg? Well, the leg is the non-parallel sides of the trapezoid. I have AB, that's one of my legs, right? Line segment AB and line segment CD, that's my other leg. So the angles that share the line segment AB, or the leg AB, they are Y and 60. Now, this property says that the consecutive angles of all trapezoids are supplementary. In other words, 60 plus 90, whoa, where did that come from? 60 plus Y, did I say 90 earlier? Anyways, 60 plus Y, alright, should give me 180. So I set up my equation just like that. Alright, it's important that you locate the consecutive angles and you don't confuse them with the base angles. Alright, a lot of students might take 60 and 4x and add them up to 180. That is not the case here. Okay, these are your base angles. So after you set up your equation like this, all you have to do is solve for y. So you get that y is equal to 120. Right? I subtract 60 on both sides to get 120. What about for x? How do I solve for x? Both of these consecutive angles here, they have variables in them. That's okay. Just set up the equation and see where it goes. Alright? Don't be afraid of this situation here. Just set up the equation. So I have 4x plus x plus 10. And that should give me 180. Alright, I set up the equation, and what do I notice? Well, I have like terms here. I have like terms. I can combine the 4x and the x to get 5x. So I have 5x plus 10 is equal to 180. Again, just use my algebra skills, combine like terms. No, don't combine like terms. You can just solve for x here. Right? You can just solve for x. Subtract 10 on both sides, I get 5x is equal to 170. Alright, and divide 5 on both sides of the equal sign, I get that x is equal to 36 degrees. Whoa! Hold up. Did I make a mistake? Yes, I did. X is not equal to 36 degrees. X is equal to 34 degrees. Alright? It's okay to make mistakes, everyone, as long as you learn from them. Alright? Alright, the special case of trapezoids we talked about was the isosceles trapezoid. Alright, remember, for the isosceles trapezoid, you're going to have two legs. Both of the legs, not the bases, both of the legs will be congruent. Now, what was special about isosceles trapezoids? Well, one of the properties of isosceles trapezoids was that the base angles were going to be congruent. They are going to be congruent. Okay, we know that the consecutive angles add up to 180. That's for all trapezoids. But when it comes to isosceles trapezoids, on top of the property we just talked about with consecutive angles, the base angles are also congruent. So what does that mean? Well, that means that 70 plus z, or excuse me, 70 degrees will be equal to z, because the base angles need to be congruent. So right away we know what z is going to be. Alright, Z is 70 degrees. Now I need to find what X and Y are. Alright, well, we know from the previous property that for all trapezoids, consecutive angles are supplementary. So in other words, 70 plus X should give me 180 degrees. Alright, using my algebra skills, right, I subtract 70 on both sides of the equation. I get that X is equal to 110 degrees. Alright, so I found what Z is, I found what X is. I need to now find what Y is. Now there are a bunch of ways to do this. There are multiple ways to do this. What I'm going to do is I'm going to use my base angles up top here, angle E and angle S. They are also base angles because they are on the same parallel line together. So I know that X, and I'll write this in red on the side here, I know that X has to be equal to Y plus 30. I just found out that X is equal to 110 degrees. So 110 degrees is equal to Y plus 30. I subtract 30 on both sides, and I get Y is equal to 80 degrees. Alright, so I found what Z is, I found what X is, and I now found what Y is. Alright, what I can also do, if you don't want to use your base angles here, you can use your consecutive angles here. Alright, and say that Z plus Y plus 30 gives you 180 degrees. You know that Z is 70, alright, and that's going to help you solve for Y. Now another thing to remember about isosceles trapezoids is that the diagonals, okay, the diagonals of the trapezoids are also congruent. So notice here I drew in my diagonals, diagonal XC and diagonal GT. They're also congruent in length. Now what happens because of this is a lot. Alright, a lot of things happen when we draw in these diagonals. Okay, you're going to notice that a lot of angles will be congruent. Okay, and that allows us to solve a lot of interesting problems. Alright, remember the problem in class where I gave you that this angle was 30 degrees? Okay, so what we concluded because of that, what we concluded when I gave you that this angle GXC was 30 degrees was that this angle over here, CTG, was also 30 degrees. And the reason or how we came to that conclusion was by using a number of cool properties that we've learned in the past. Alright, we mentioned something about the reflexive property. Right, GC is congruent to itself because of the reflexive property, and we mentioned the special triangles. I mean, not special triangles. Sorry. We mentioned the triangle congruent shortcuts. Right. We got SSS with these two triangles here. Right, triangle GCX and triangle CGT. So we used SSS, and then we knew that these angles would be congruent because of CPCTC. Alright, so that's just a quick reminder of what happened in class. We used very similar logic. Right, we used very similar logic to come to the conclusion that these angles over here would also be congruent. And also, these four angles over here would also be congruent because of alternate interior angles. Alright, so I'll draw an angle with two dash marks just like that. Alright, so I know this drawing looks very complicated, but you can rewatch this video a bunch of times until you get it. Okay, this is actually a very I had a good time in class today going through all of these steps with you, alright, to help you realize that all of these different angles were congruent to each other. I had a really good time, so I thank you for that.